Om Sri Sai Ram. My humble salutations to my beloved Bhagwan, respected elders, and my dear students. Once again, hearty welcome to National Mathematics Day 2020. Today, I would like to give some example of the beauty of maths and the music. So, let me start with a small definition of the group. Everybody knows that a non-empty set together with a binary operation satisfies the following properties. For all ABC in G, the closure property AB is a member of G. Associative property AB times C equal to A times BC. Identity, there exists E belongs to G such that AE is equal to A. And inverse, there exists B belongs to G such that AB is equal to E. And then we have got some example. Set of all non-zero real numbers together with multiplication forms a group. Similarly, set of natural numbers together with addition forms a group. Now, a non-empty set together with the binary operation satisfies the following properties. And we also know that it's a cyclic group. So there is an element in a group which generates the whole group. So with single group element, all the elements will be generated. Example, set of integers under addition forms a cyclic group. On the other hand, clean 4 group EABC is not a cyclic group because we cannot find an element in this clean 4 group which generates all the other elements in G. With those two examples, we'll start the example of that is music. We are going to compare. What is this? Western music consists of 12 notes as follows. What are they? C, C sharp, D, D sharp, E, F, F sharp, G, G sharp, A sharp, and B. So like this, there are 12 notes are there. And then these 12 notes are divided into 12 intervals. And each interval is having certain names. That is, here we see the interval name is unison, that is from C to C. Semitone, C to C sharp. Whole tone, C to D. Minor third, C to D sharp. Major third, C to E. Perfect fourth, CF. Tritone, C to F sharp. Perfect fifth, CG. Minor sixth, CG sharp. Major sixth, C to A. Minor seventh, C to A sharp. Major seventh, C to B. So this is just like 12 notes 12 intervals are there. And then I'm going to call them by the names. This is 0, let us say. This is the interval 1. This is 2. This is 3. And then we are having that is equal to. Okay. So once again. So this is 1, 2, 3, 4, 5. And then I will call this as 6, 7. And this is 8. This is 9 and 10. I'm sorry. This should be, we'll start with 0 actually. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, and then we are having 9, 10, and the last one is 11. Okay, this is how we call it as. Okay, now, so we see, consider. We can verify all the axioms of groups. So C to D plus, so we are on this, we are going to have, these are the set. What are the elements? 12 intervals are there. They are the members of the group G. And then we are going to define a binary operation, that is addition modulo 12. That is A plus 12B. What is A plus 12B? Let me write it down. A plus 12B. So what is nothing but, everybody knows that, that is nothing but some T, where T is the remainder obtained by dividing A plus B by 12. Okay, am I right? So here what is that we are going to do? CD, C to D. This C to D is the interval to CD, and then CE is the interval 4. Okay, C is the interval 4. So automatically C to D interval, that is second interval, and C to E interval, fourth interval. When you add these two, we will get the interval 6, that is CF. So when you add two intervals, next interval is also addition of these two intervals under addition modulo 12 is again a member of G. Therefore, it is closed. And further, we can verify again the associative property. What is the associative property? That is CC. What is CC? CC is nothing but second one. Okay, if you observe, this is 0 plus, and then C to D. CD is 2. So 0 plus 2, and then to this we are adding the another interval. What is that interval? C to E, that is equal to 4. So this is the left hand side. Then what is there on the right hand side? We get C to C sharp, that is C to C sharp, sorry, this one, I made a mistake. C to C sharp is 1 actually. Okay, C to C sharp, C to C is 0, this is 1. Okay, so this is 1. Okay, C to C sharp 1. Next C to D, that is 2, and then C to E is 4. So this is true. So associative law is verified. Okay, next C to C. C to C is third property, that is 0. This identity, everybody knows that. Okay, so this exists. And then we are having C to D sharp. So fourth property, existence of inverse. What is C to D sharp? C to D sharp is, again, this is 3 plus C to A. C to A is 9. So 3 plus, this plus is related with respect to addition modulo 12. So 3 plus 9 addition modulo 12 is nothing but that becomes equal to 0, CC. So inverse also exists. So for the interval C to D sharp, that is 3, the inverse is C to A. So that you will get the 0 interval. Okay, so easily we can see that they form a group. And further, what are the generators? For the generators, everybody knows that the number of elements in G, the number of elements in G is 12. How do you write 12? You write that as product of two prime numbers, that is 2 square into 3, we can write. Okay, so what is the number of generators? There is a formula, Euler's formula, that is we can write this as phi of 12. What is phi of 12? All those elements which are prime to 12. What are the elements which are prime to 12? 1, and further we are having 5. The GCD of 5 and 12 equal to 1, and another one is 7. 7 is also prime to 12 and the relatively prime to 12, and 11. So we are having 4 generators. 1 means C sharp, 5 means the interval C to F, 7 means the interval C to G, and 11 means C to B, that is. So these are the 5 generators. So it is a beautiful application that today we are learning the significance of group theory, cyclic groups, and the music. Thank you very much for watching this video.